When you work with arrays, you'll find yourself sometimes wanting to make a copy of the array so that you can then manipulate the copy and leave the original unchanged. This is perfectly easy to do in processing. It takes no work at all, but it is a little bit odd in that you don't do it the same way you copy normal variables. So in this video, I'll show you the right way to do this. Let's begin with an analogy. Suppose that I create an integer called a, and I give it the value 5. Okay, no surprises here. I'm about to create another variable called b, so I'm going to make a little table of the values for a and b. Right now, a is 5 and b doesn't exist yet. Now I'm going to create b, and I'll say int b equals a. Well, we know what happens. We take the value that's in a, which is 5, and we put it into b. So now both a and b are 5. But a and b are two completely separate objects, and they're not related in any way after this assignment statement. So if later on I say b equals 7, nothing happens to a, and if later on I say a equals 2, nothing happens to b. They're two completely different objects. The only time they were connected was when I said b equals a, and that just took the value in a and dropped it into b. Otherwise, they have no connection. Let's take a look at the analogous situation with arrays. Here's our old friend, an array of integers, and I'm going to put the integers into the array in a little bit of a scrambled order just for fun. So this is our array A. I'm going to make a copy of it called B, and I'm going to change B sub 3. Remember, we start counting at the left with 0. So B sub 0 is the orange ball numbered 5, B sub 1 is the 4 ball, B sub 2 is the 3 ball, and B sub 3 is the yellow 1 ball. Now we want to replace that with the value 12, so no problem. We take the value 1, we get rid of it, and we put the value 12 inside. A still has the original values. A is unchanged. B has a different number in B sub 3. This is what we want to have happen. Let's see how to bring it about. I'll start by declaring an integer array A, and I'll just load it up with the 6 numbers we already have. Now I'll create a new array called B, and I'll make sure that B is as long as A. I'll create enough memory for B to hold all the elements of A. And now, in analogy with what we did at the beginning, I'll just say B equals A. And it turns out this is almost never what you want to do. Because inside of processing, assigning an array with an equal statement like this means something special. It means A and B are two names for the very same object. And it turns out that this is almost never what you want. Because inside of processing, assigning one array to another like this, B equals A, does the following weird thing. A and B are now two names for the very same array. Remember, in our first slide, I had two integers, a and b, and they're completely unrelated. But when we say b equals a and b are now two names for the very same array. They're like two labels on the same box. So if I say b sub 3 equals 12, and we replace b sub 3 with the value 12, a sub 3 has changed as well, because a and b are the very same list of objects. So this is almost never what you want, because why did you make a copy in the first place unless you wanted to manipulate it separately from the original? If you wanted to manipulate A, then you wouldn't have made the copy at all. So how do we actually make a real bona fide copy? Well, we know it's not by saying B equals A. That does this weird thing where they both are names of the same list of objects. So let's get rid of that. The right way to make a copy of A and put it into B is to use the routine array copy. This is what we wish the equal sign did, but this is the way to do it. So you say array copy, the array you want to copy from, and the array you want to copy to. And this runs through the array A and takes each element and assigns it to the corresponding element of B. If we do this, now we have a new array called B. And if I say B sub 3 equals 12, then great, we replace B sub 3 and A is unchanged. So this is the only thing you have to remember. The trick is, if you want to make a copy of an array, Don't do that. Don't say B equals A. Instead, use array copy. That's what it's for, and that's what it does. Let's take a look at this in action, in running code. Here's a little sketch of a bunch of balls that are just dropping from the top of the screen. When they fall off the bottom, they start again at the top, and the big balls fall a little bit faster than the small ones, and so if we let it run for a while, we get this kind of a pattern. And this will just go on forever. Of course, I'm doing everything here with arrays. What I would like to do with this program is to add drop shadows. I want to draw a little dark shadow behind each ball. So let's take a look at the code and think about how we would add drop shadows. Here's the code. Well, there's a bunch of stuff we don't care about, but let's focus on the things we do. We have 3 floating point arrays, and they hold the X and Y centers of each ball and its radius. Okay, setup is not that interesting. We call size and smooth. I say I want 10 balls. Now I allocate the 3 arrays, and then I run through a little loop. And I'm doing a little bit of arithmetic here that I won't go into. If you're really excited by this sort of thing, you can draw a little picture and figure out what this is doing. All it's doing is spacing out the balls horizontally across the screen. The Y value starts just above the top of the screen, so the bottom of the ball is just touching the top. And then the radius, I use map to take I, which goes from 0 to num balls, and I map that to 20 to 50. So the balls get bigger as I work my way to the right. Let's take a look at draw. All it does is set the background, set the fill color, and then it calls a routine called draw balls. And it hands to that routine the array of X centers, the array of Y centers, and the array of radiuses. So let's take a look at draw balls. You can see it takes 3 input arrays, which for convenience, I'm just shortening the name. So the first array I'm calling XC for X center, YC for Y center, and R for radius. And now I just draw the balls. I have a loop that goes from 0 to X center dot length. I call ellipse, and I draw the ball centered at XC sub I, YC sub I, and twice the radius, sub I. Then I add to the Y center 0.1 times the radius of that ball. That just makes the ball go down, and it makes the bigger balls go down a little faster. And Y 0.1, well, I pulled that out of thin air. I actually played with that number until it looked like it was running at a nice speed on my computer. And then I said, hey, if the top of the ball, Y center minus radius, is greater than height, in other words, if the top of the ball has fallen off the bottom of the screen, well, then we just start over again. I take the Y center and I make it the negative of the radius. So let's run it again to remind ourselves of what this thing does. And now I want to figure out how to draw little drop shadows behind each one. So you know what I'm going to do? I'm going to make a copy of the array. So let's give that a shot. So let's figure out what the offset should be. I'll create a couple of floats. I just kind of guessed at some values. I hope that that'll look kind of nice. So the strategy is I'm going to make a new pair of arrays. Instead of using X center and Y center, I'll make copies of X center and Y center, and then I will displace them by the shadow. And then I'll draw those, and then I'll draw the X center and Y center arrays. The first thing I'll do is I'll create the new arrays. Now the next thing I want to do is to copy the centers into the shadows. So I'll leave that as a comment for the moment. And now I will offset the shadows. Now I need to draw the shadows, and I'll tell you what, I'm going to fill it with black, but I'll make it slightly transparent. So it's a dark black, but not the darkest. And I'm going to turn off the strokes because I don't want to stroke around my shadow. And I'll call draw balls using the new centers, shadow X and shadow Y, and the same radius as before. Then I'll remember to turn strokes back on and draw the balls. So now the only thing we have left is to copy the center arrays into the shadows. And let's do it the wrong way. I'm just going to say shadow X equals X center and shadow Y equals Y center. All right, let's run this and see what it does. Oops, I have a problem. And I forgot to declare these as arrays of floats. Okay, let's try it again. Okay, something's going crazy wrong, and it's not even drawing anything anymore. Everything is now off screen. So I'll tell you what, I'm going to run it again, but let's look really closely and see if the shadows are even getting drawn. Yeah, they are. What's going wrong, of course, is I'm copying the arrays using these assignment statements. And as we saw, that's just wrong. And it's just causing things to go haywire. And if you're into it, I invite you to think about what's going on and why it's going haywire in this way, and you can figure it out. And it's actually a worthwhile thing to think about and try to figure out why it's going wrong in this way. That'll help you understand why you don't want to do this. So I'll tell you what, let's do it the right way. I'm going to say array copy from X center into shadow X, and array copy Y center into shadow Y. Now let's run the program. And we have our drop shadows. So this is why you want to use array copy. Now I'm making a copy of the centers. I'm displacing the copy. I'm moving it right and down a little bit and drawing them as shadows. And I'm not changing the original values. If you keep this in mind, you can make as many copies of arrays as you like, and everything will work properly.